All right, get ready, because today we're going depth on something that might just spin your head a little bit.
Literally.
Yeah, literally. We're diving into the shape of our planet,
Ooh.
which you might be thinking, wait a second, isn't that like settled science?
Right?
And yeah, you're totally right. But believe it or not,
Mm-hmm.
even in 2024, there are still some folks out there clinging to that whole flat Earth idea.
It's wild.
So we're going to tackle this from both sides. We're going to debunk some of those flat Earth myths,
Love that.
but we're also going to uncover some seriously cool, maybe even mind-blowing facts about the true shape of planet Earth. Ready to get spherical with it?
I am so ready. You know, what I think is really fascinating is the evidence for a spherical Earth is not new.
Yeah.
At all. We've got excerpts today from a modern Earth scientist, which is awesome,
Of course, yeah.
but also a government website, absolutely packed with facts. And we've even got a BBC article that looks at how this whole flat Earth belief has managed to hang around for centuries.
Okay, so like right off the bat, I'm curious. If like the ancient Greeks figured out the Earth was round over 2,000 years ago, why is this even still a thing?
Yeah, that's a great question. It's definitely complex, but the BBC piece kind of touches on this idea that, throughout history, people have gotten new information, and sometimes they've resisted it.
Yeah.
So sometimes those old ideas, they just kind of stick around, even if science proves them wrong. But I think for this deep dive, let's focus on that science, because it's pretty awesome.
Okay, let's do it.
Our Earth scientist source explains how, ships disappearing hull first over the horizon, that's one piece of evidence.
Oh, yeah. Like when you're at the beach and as the ship sails further away, it looks like it's slowly sinking.
Right.
If the Earth was flat, shouldn't we just see the whole ship getting smaller and smaller?
Exactly. You just see it shrinking.
Right.
But that gradual disappearance from the bottom up, that only makes sense if the Earth's surface is curved.
Makes sense.
And that curve leads to some other pretty cool observable things, like different shadow lengths at different locations at the same time.
Wait, okay, now shadow lengths sound kind of boring.
I know.
But I'm intrigued. How does that prove anything?
Well, think about it. If the Earth was flat, the sun's rays would be hitting every point at basically the same angle.
Right.
Which would mean identical shadows everywhere.
Okay, yeah.
But we know that that's not the case. Shadows change length throughout the day, and they're different lengths at different latitudes, and that's because the Earth's curvature. It means different places are tilted towards the sun at different angles.
Ah, so that's why we have time zones. Because different parts of this curved Earth are facing the sun at different times.
Exactly.
Okay, yeah, that makes total sense.
And speaking of things that wouldn't make sense on a flat Earth, let's talk about lunar eclipses.
Oh, yeah. Those are always so cool to watch.
Yep.
How do those prove the Earth isn't flat?
Well, during a lunar eclipse, the Earth passes between the sun and the moon.
Right.
Right.
And it casts its shadow on the moon's surface. And that shadow, always round. Now, if the Earth was flat, like a disk,
Right.
that shadow would totally distort as the Earth rotated. Sometimes it'd be a line, sometimes an oval, but that's not what we see. It's always a round shadow.
So even thousands of years ago, people could look up at a lunar eclipse and be like, oh, Earth is a sphere.
Basically.
That's wild.
Isn't it cool? Our scientist source also throws in a photo of Mars as evidence, which I love.
Of course.
It's a great visual reminder that we can see other planets as spheres.
Yeah.
So Earth's no different. It fits the pattern.
Makes sense.
But here's where things get even more interesting.
Here's where it gets really interesting. Okay, I love this part.
Buckle up. Our government source, NOAA, they describe the Earth not just as a sphere, but as an irregularly shaped ellipsoid.
An irregularly shaped what now? Okay, I need a little help with this one. What does that even mean?
Okay, so it means the Earth isn't a perfect sphere.
It bulges at the equator because of its rotation. Think about spinning like a ball of dough.
Oh, okay.
It kind of flattens out a bit in the middle.
So like a slightly squashed sphere.
Yeah, you could think of it that way.
But if it's irregular, it's got to be more than just squashed, right?
Oh, it's definitely more complex than that. We've got mountains, valleys, deep ocean trenches, all contributing to its irregular shape.
Okay.
And get this.
Yeah.
Even sea level isn't actually flat.
Wait, what? Hold on. Sea level isn't flat. I thought, by definition, sea level was. Sea level.
Right.
Explain this to me.
So it's true. Sea level, as we conventionally understand it, is a simplified model. The Earth's gravity isn't uniform across the surface.
Okay, now that is blowing my mind a little bit.
Right.
So you're saying, gravity isn't the same everywhere on Earth.
Exactly. And that variation in gravity, you know what it does? It causes permanent hills and valleys
Oh, wow.
in the ocean surface.
Really?
Some, get this, hundreds of feet high
No way.
or deep.
Wow. So we've got mountains on the land and then like underwater mountains in the ocean
Yeah.
because of gravity.
Yeah. It's pretty wild.
I am picturing like the ocean as this bumpy, lumpy surface now.
It's pretty amazing, isn't it? And this irregularity, it's further influenced by something else.
What's that?
The moon's gravity.
Wait, the moon? I thought we were done with the moon after that whole lunar eclipse thing.
Not quite. Remember how the moon's gravity causes tides?
Oh, yeah.
Well, it also has a subtle but measurable effect on the Earth's crust.
Hold on, I need a visual here. Are you saying like the moon is literally pulling the Earth's crust towards it? Like the ground I'm standing on is being tugged on by the moon?
It is. The moon's gravitational pull, it creates these bulges
Okay.
in the Earth's crust. You mostly notice them on the side facing the moon
Right.
and the opposite side.
So the Earth is kind of like a giant stress ball
You got it.
being squeezed by the moon.
Yeah, kinda.
That is so cool,
Yeah.
but also kind of freaky.
It's true. It paints a pretty fascinating picture, right?
Yeah. So these bulges, they're not stationary, right?
Nope. They move as the Earth rotates and the moon orbits us.
So the Earth is constantly being reshaped,
Yeah.
even if it's just tiny little bulges here and there by this cosmic dance with the moon.
Exactly. Which brings us back to that NOAA website and their point about Earth constantly changing.
Right.
We've talked about tides, the moon's influence,
Uh-huh.
but there's also the long game, tectonic plates.
Oh, right. Those like giant puzzle pieces that make up the Earth's crust.
They're always moving.
Right. How much are we talking here?
So the movement is super slow,
Okay.
only a few centimeters per year,
Okay.
but over millions of years, those centimeters add up
Right.
to huge shifts.
So you're saying like millions of years from now, the continents could look totally different? Like North America could be snuggled up next to Australia?
It's entirely possible. The Earth's surface is dynamic, constantly in motion.
Wow.
Mountains rise, oceans widen, continents drift.
So like the maps we use today, they could be totally outdated in the future. That's kind of amazing, but also mind-boggling.
Yeah, it's pretty wild to think about.
So what else could change about Earth's shape millions of years from now?
That's the question scientists are constantly exploring. There are so many factors at play, volcanic activity, erosion, even asteroid impacts. All of these things can contribute to shaping the Earth's surface over time.
It's like our planet is this giant art project, and it's constantly being sculpted and reshaped by all these powerful forces.
Wow. Love that analogy.
But if we zoom out even further, beyond millions of years, what about billions of years? Like, what could Earth look like then?
Wow. Okay, so we started by asking, is the Earth flat?
Right.
And look where we ended up. We've explored, ancient Greek astronomy, lunar eclipses, the moon tugging on our planet's crust,
That's pretty amazing.
tectonic plates. We even talk about the future of our planet's shape. This deep dive has taken us on quite a journey. It has. But before we get too carried away with the distant future, I want to come back to something you mentioned earlier.
Okay.
You asked about actually seeing these changes in Earth's shape.
Oh, yeah. Is that even possible? I mean, we know, mountains grow and continents drift, but it's all so slow, right?
Right.
It's not like we can watch a time-lapse video of Earth changing shape.
You're right. These processes take millions of years.
Yeah.
But we do have tools that let us track these changes, even if it's on a slightly smaller scale.
Like what?
Things like satellite imagery
Oh,
and GPS data, they can detect tiny shifts in the Earth's surface.
hold on. So we can actually see, a volcano growing or, a fault line shifting
Yeah.
using satellites.
Not exactly in real time, but by comparing images taken over years or even decades, scientists can measure those minute changes. They can even create maps and animations
Cool.
that show how the Earth's surface is constantly moving and reshaping.
That's awesome.
Yeah.
So we're not just passively observing these changes anymore. We're actively measuring them, tracking them. It's almost like we're taking the Earth's pulse.
Exactly. And
Yeah.
that data isn't just for scientific curiosity, It
Oh.
helps us understand things like earthquake risks,
Okay.
volcanic activity,
Yeah?
even the effects of climate change on coastlines.
Oh, wow.
It's practical information that helps us make informed decisions about our future.
So by understanding Earth's shape and how it changes, we can actually help protect ourselves
Mm-hmm.
and the planet. It's like knowledge is power, literally.
It really is. And it brings us full circle to the importance of scientific inquiry.
Right.
By asking questions, by observing the world around us, by developing new technologies, we gain a deeper understanding of our planet and
Yeah.
our place in the universe.
Absolutely. And remember, even though this deep dive is coming to an end, the exploration doesn't have to stop here.
So true.
There's a whole universe of fascinating facts and incredible discoveries out there.
Keep asking questions, keep learning, keep exploring.
Yeah?
Who knows what amazing things you might uncover?
Couldn't have said it better myself. So until next time, keep those brains buzzing, and remember, the Earth is round,
Yeah.
but it's definitely not boring. Thanks for joining us on The Deep Dive.